Hello friends, in this video I am going to discuss one more theorem which is based on concept of moment of inertia, that is perpendicular axis theorem. So let's start the discussion of perpendicular axis theorem as per the concept of moment of inertia. So here, if we define the perpendicular axis theorem, so basically perpendicular axis theorem we generally define on the basis of this particular diagram. Here we consider third direction also. Previously I have discussed about the parallel axis theorem, which is based on two dimensions or plane lamina, and that dimensions generally considered in x direction and y direction, and here we are considering three dimensions like x direction, y direction and z direction. All three directions we will consider in perpendicular axis theorem. So if we define the perpendicular axis theorem, so it is the moment of inertia of plane lamina about any axis which is perpendicular to the plane lamina, it is equals to sum of the moment of inertia of the lamina about two axes which are right angle to each other and intersecting each other at a point where perpendicular axis passing through it. So it is based on three directions, x direction, y direction and z direction. So here, as per the perpendicular axis theorem, if we are considering the moment of inertia of any plane lamina about any axis which is perpendicular to the plane lamina, so let us consider the z axis is the axis which is perpendicular to the plane lamina, and that particular moment of inertia about the zz axis or z axis for the plane lamina will be equals to summation of the moment of inertia of the lamina about two axes which are right angle to each other. It means if we are taking z axis for the main moment of inertia of the plane lamina, so it will be equals to summation of moment of inertia of the lamina about x-axis and the moment of inertia about y-axis, because x-axis and y-axis are generally considered as perpendicular to each other. So this moment of inertia of the plane lamina about zz axis will be equals to summation of moment of inertia of lamina about xx axis and the moment of inertia about yy axis, and we can write down the equation as per this concept. It is izz equals to ixx plus iyy. So here we have all three moment of inertia about zz axis, moment of inertia of plane lamina about zz axis which is perpendicular to plane lamina, and ixx axis is the moment of inertia of the lamina about xx axis, and iyy is the moment of inertia of the lamina about yy axis. Now here let's see the diagram. So here you can see in this particular diagram there are two axes we are considering. One is the x axis and another is the y axis, and here we are taking point O as the intersection point of this x-axis and y-axis. So let us consider this OX axis and OY axis where this lamina is existing. So this OX axis and OY axis we can consider it is lying in the plane of lamina, and here this is our lamina and we are taking the area of the lamina is A. And here in this particular lamina, we are considering a small elemental component. This particular component we are taking in this particular lamina with area dA. And the distance from the OX axis for the small elemental component we are considering y, and from y axis or OY axis the distance of this small elemental component we are taking as x. Now here we are taking x axis and y axis. Now let us consider there is another axis which is perpendicular to this lamina. So this OZ axis is represented as the perpendicular axis from this particular lamina. So here and the distance of this particular OZ axis, which is perpendicular to lamina or this small lamina, is r. Here we have three dimensions: x from the y-axis, y from the x-axis, and r, which is perpendicular from the OZ axis. So in this OZ axis, we are taking the dimension that is r. Now, if we want to find out the value of IZZ, so the value of IZZ, as per this concept, with the help of this r, it will be dA r square. And here we are taking a small elemental component. Now, if we find out the total moment of inertia for this complete lamina about ZZ axis, so it is represented by summation of dA r square. So here IZZ, I have already written here the moment of inertia of the lamina about ZZ axis, which is perpendicular to plane lamina. So it is IZZ, that is equals to summation of dA r square. And here, as per this diagram, we can write down this equation. Summation of dA into x square plus y square. Here, if we are taking r as a resultant of x and y, so r square will be equals to x square plus y square. So we can write down this as the equation of IZZ. Now here, if we solve this equation, so it will be IZZ equals to summation of dA x square plus summation of dA y square. And this summation of dA x square, we are taking the moment of inertia of the lamina about y axis, and summation of dA y square, we are taking moment of inertia about x axis. So here we have this summation of dA x square as the moment of inertia of the lamina about y axis. So this we can represent as Iyy, and summation of dA y square as the moment of inertia of the lamina about x axis. So this we can represent as Ixx. So the final equation of IZZ will be IZZ equals to Ixx plus Iyy. This Ixx is representing summation of dA y square, and this Iyy is representing summation of dA x square. So this is our perpendicular axis theorem, which is based on three dimensions of the plane lamina. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.